Hello students, I am coming for a new class. We are discussing electrostat, how to calculate force acting on big size object. The last thing we discussed, how to calculate force acting on a point charge Q. How to calculate force acting on a point charge Q due to a uniformly charged ring of radius r. If a ring of radius r present and a point charge is kept at some distance x, then force acting on the point charge, as whole calculation shown in my last class, it is capital Q small q x by 4 pi epsilon naught r square plus x square, everything to the power 3 by 2. So we discussed up to this one in the last class. It was a ring, force acting on the point charge because of the ring. We are discussing how to calculate force acting on big size object. So one point charge and one big size we are doing. Okay. After that, this idea of ring I want to extend to a disc. Say for example, now this is over. Now I am considering that a circular disc present. It is not a ring, it's a disc. So for example, this disc is charged and it is carrying total charge Q. It is of radius say r, and I am considering a point charge Q here at some distance x. You should write the question first. As you know, I always want pen and paper from your side, so you should be ready with pen and paper to write the question. You write the question first. Figure shows a uniform circular disc of radius r carrying total charge q with a point charge small q at a distance x from the center on its axis. Meaning whatever the disc, it is the disc, clear, and the point charge is along the axis of the disc, clear. So along the axis of the disc, the point charge present. Find the force acting on the point charge Q. So I am repeating it. Figure shows a uniformly charged circular disc having radius capital R carrying total charge capital Q. Find the force acting on a point charge Q at a distance x placed on its axis. Okay. Now look at, it's a point charge, for that law is valid, but disc is a big size object. Coulomb's law directly not valid. Now disc is a big size object. We can consider this disc is made up of some circular rings. Meaning I am drawing it separately. Say this is my disc. I am assuming the disc is made up of some circular ring like this. The point charge Q present at some x distance, the point charge present. I am not altering this part. Radius of the whole disc is r. I am not changing that radius. Just what I am assuming, the disc is made up of some circular ring like this. Each such circular ring concentric, and this concentric circular ring one after the other. Clear? So one ring here, the next one is here, third one is here, fourth one is here, making a disc. So I am considering it is of radius smaller, thickness dr. Charge of this ring, say for example dq. Now look at, already we know the formula for a ring. If a ring present, force is given by this. In my question it is not a ring, it's a disc. I am assuming the ring is made up of the disc is made up of some ring. One such ring I am assuming here, it is of radius r, it is carrying dq charge. So force because of this considered ring I am writing. Yeah, it is not the force because of whole disc, force because of this ring only. Force because of this ring only, meaning that considered ring, by this formula, it is dq into q into x. Actual formula is capital Q small q into x. Capital Q should be the charge. Here whatever ring I am assuming, it is carrying dq charge only. So divided by 4 pi epsilon naught small r square. Look at the ring considered by me, it is of radius r, and formula of force because of a ring is given by this equation. Then 4 pi epsilon naught r square plus x square to the power 3 by 2. Actual formula was capital Q small q x by 4 pi epsilon naught bracket capital R square plus x square. Why? Because in that ring where the derivation shown in my last class is R square plus x square to the power 3 by 2. My advice is you should go to the class serially. You should not jump into a new class without going to the previous one. Just go serially, it will be easy for you to understand. In competitive exam, you should know it thoroughly, so I am discussing. Okay. Here, small r, as we have to consider the whole disk, small r to be integrated from 0 to capital R, and dq also to be integrated. So, two variables simultaneously we cannot integrate, no scope available. So, I am just modifying what is dq. How to do? This dq can be modified easily by this idea. Q amount of charge present in the whole disk. So Q amount of charge present in the whole area pi r square. We are interested in this portion. Here, this is a ring. This ring, if you consider it is of radius r, thickness dr. So area of this one is twice pi r dr. So what is done? Q amount of charge present in the whole area pi r square. We are interested in this area. So Q by pi r square multiplied by twice pi r dr. In that way, dq can be simplified. Pi goes cancel. It is Q twice Q r into dr by r square. 1 pi here goes cancel. Let me write dq here. If you write value of dq here, 1 2 and 1 2 goes cancel. It is capital Q small q x by 2 pi epsilon naught. Why 2 pi? Actually it is carrying 4 pi, but 1 2 present here. If you put that value of dq, this dq is replaced. Then r dr divided by r square plus x square to the power 3 by 2. So this is df, meaning force because of this ring. Now good thing is, once this replacement done, the variable available is r, because x is a fixed thing. This x, whatever we are looking at, x is fixed thing. Only variable is r in the equation. R should go from 0 to capital R. So total force I want to calculate. It is capital Q small q x by twice pi epsilon naught integration of r into dr divided by r square plus x square to the power 3 by 2. Integration should be done from small r equal to 0 to capital R. Now directly there is no formula to integrate this one, so we have to use some manipulation. I am going to show this quantity. I am assuming here, let z square equal to r square plus x square. I am just assuming this quantity as z square. Let me differentiate with respect to r. So twice z dz by dr. This is r square, differentiation twice r. This x is a constant, differentiation 0. So 2 here and 2 here goes cancel. Z into dz, nothing but r into dr. I hope this step clear. Now this r into dr, I am going to write z dz. R square plus x square, if you write z square to the power 3 by 2, 2 and 3 by 2 half goes cancel, only 3 left. So it is capital Q small q x by twice pi epsilon naught integration of z dz divided by r square plus x square is z square, square and half goes cancel, so z cube. I am going to put the limit later on, just wait. capital Q small q x by twice pi epsilon naught. It is integration of dz by z square. I am going to use the limit letter weight. It is capital Q small q x by twice pi epsilon naught dz by z square integration of minus of 1 by z. Integration of dz by z square coming from a formula directly. So it is minus of capital Q small q x by twice pi epsilon naught. What is z? Let me replace. Actually z square is r square plus x square. So z is under root r square plus x square. Limit present. Limit should go from small r equal to 0 to capital R. Actually limit for z is not known. That is why no limit written. Z is replaced in terms of small r, then limit known. Small r should go from 0 to capital R. Now simplification will give the answer. What is simplification? Simple. It is minus capital Q small q x by twice pi epsilon naught. Always final minus initial. Finally small r becomes capital R. So it is 1 by under root r square plus x square minus 1 by x. Why? R is 0, x square with root becomes x. Yeah? It can be further written like this. F, I want to put the minus inside, I want to put x also inside. It is capital Q small q by twice pi epsilon naught. In the whole writing, this r square is left out. Yeah? This r square left out. So you should write this r square. Here, this r square left out. This is the r square. This is that r square. Here also r square present. 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 It's a mathematical step. Actually when you write dq, here dq replace that r square left out. Sorry. So capital Q small q divided by twice pi epsilon naught r square. I am going to put the minus sign in. I am going to put x also inside. It is 1 minus x by under root r square plus x square. So this equation gives us force acting on a point charge. Force acting on a point charge small q due to a disc. I hope no difficulty in that. At the time of doing calculation, there is no ready-made formula for discs. So I am repeating it what is done. First of all, there is no formula for the disc. So I am considering the disc is made up of some rings. Place concentric one after the other to make the whole disc. Because of a small ring like this, yeah, by using the formula of force due to ring, force written. What is dq written by unitary method? Then all this simplification gives the answer of the force. Yeah? My advice is go through the calculation, don't jump any step, try to do everything from your side. If any mathematical mistake in between, you can very easily correct it. I hope the concept is perfect. Thank you, students.